So the topic for today is the greatest common factor and factoring out the greatest common factor from polynomials. This entire unit that we're going to be working on is about factoring. And here's what you need to remember about this. A factor times a factor equals a product. All right, just so you're familiar with the vocabulary. Factors are things you multiply together. Product is the answer that you get when you multiply them. This whole unit has to do with taking a product and figuring out what factors you can multiply to get that product. All right, so we are going in reverse from the product to the factors. So vocabulary, a factor is something that is multiplied. A factor can be a number, a variable, a monomial, or even a polynomial. Two factor, so that means a verb. Two factor means to write something as a product of its factor. So in other words, to write it as factor times factor. That's what factoring means. So if I ask you to factor something, you're going to take the product. You are going to write it as a factor times a factor. Or maybe a factor times a factor times a factor, because it could be 3 factors. Or even 4 factors. All right? A number or expression is called prime if its only factors are 1 and itself. So in other words, if I can't break it up into 2 different factors where one of them isn't 1 and the other one isn't itself. The greatest common factor, GCF, of 2 numbers or expressions is the largest number that is a factor of both of the numbers or expressions. So that's what a GCF is. And you should remember GCF from your middle school math years. And the first thing we're going to do today is to figure out how to find a GCF. And sometimes it can be hard because we don't necessarily know the largest number that divides into 2 numbers. We may know a number, but not necessarily whether or not it's the largest. But we've got a process that we can use that will help us get that answer. So if I want to find the GCF for 72 and 108, and I don't know what this is off the top of my head, I'm going to write a 72 and a 108 with a comma in between them, and I'm going to put a little, it's like a half of a box around them. Now, by my multiplication tables, I happen to know that 9 divides into both of these. So I'm going to write a 9 here beside my box. Below my box, I'm going to write 72 divided by 9 gives me 8, and 108 divided by 9 gives me 12. So now I have 8 and 12, and I ask myself what goes into both of those. And it doesn't have to be the largest thing, just something that goes into both of those. And I know that 4 goes into both of these. So I'm going to write a 4 out to the left of the box. 8 divided by 4 gives me 2. 12 divided by 4 gives me 3. Now I have 2 and 3, and I put a little half of a box around them. And I can't go any further because there isn't any number other than 1 that divides into both 2 and 3. But what this process gives me is an answer to my question, what is the greatest common factor? Since 9 divides into it and 4, my greatest common factor is 9 times 4, which is 36. So this process can help me find my greatest common factor. And it's great because I don't have to do it all in one step. I can take multiple steps to do this. So the next thing I'm going to do is I'm going to do this same process, but this time I happen to have variables. Don't worry, we did this in Algebra 1. It will come back to you quickly. So I'm going to draw my half a box around here. And I'm going to ask myself, what divides into both of these terms? Now, into 8 and 12, a 4 divides into both. What I'm going to do is take 8ax squared and divide by 4. And I'm going to get 2ax squared, comma. Now I'm going to take 12a squared x and divide by 4. And I'm going to get 3a squared x. Now, what else goes into both of these? Well, 1a does, and 1x. So I can take out an a and an x. From here, what I'm putting right here is really this. 2ax squared divided by ax. And what this gives me is 2x, because the a's cancel and my x's have 2 minus 1 or a power of 1. So I have 2x left. Here, what goes here is this, 3a squared x divided by ax. The x's cancel, and the power of a is 2 minus 1, or just 1. So right here I have 3a. And now, nothing goes into both 2x and 3a. So what I have here is a 4 and an ax. So my greatest common factor is these two things multiplied, 4ax. Now when you're looking at two monomials that have exponents, or variables with exponents, the greatest common factor of the variables is the smallest power that they share. The smallest power of a is a to the 1 power. The smallest power of x is x to the 1 power. So in the greatest common factor, we're only including a to the 1 and x to the 1 power. It's the smallest power of that variable that we include in our greatest common factor. So let's go ahead to C. And when we go to C, we're going to draw our box. And what goes into 48 and 60, if I think of my multiplication tables, I can take out a 12. 12 goes into 48 4 times, so I have 4x squared y squared. And 60 goes into 12 5 times, so I have 5x y to the third z. And now I'm going to take out my variables, because 4 and 5 don't have any more common factors. So I'm looking for my smallest power of x's, which is x to the 1 power. My smallest power of y's, I have y squared here and y to the third here, so my smallest power is y squared. And then I look at z's. This one doesn't have a z, so I can't pull a z out. So what I have left when I take out 1x and 2 of the y's is 4x. All right? Now, take a look at this. I'm going to take out the x. So I have the 5. I have no x's. I had 3 y's. I'm taking out 2. So I have 1 y left. And I have a z left. And what you're going to notice now is that 4x and 5yz have no factors in common. So I can't go any further. So my GCF is 12x y squared. All right, let's go to the next page. It says find the GCF of each set of numbers. And this time I've got 3 of them. And in order for me to pull it out here in front, it has to go into all 3, not just 2 of them, but all 3. And I don't know what goes into all of these, but I'm thinking 2 because they're all even. So I'm going to pull a 2 out. I'm getting better at this, so I'm going to take a leap and I'm going to pull out my variables as well. I have some x's. The smallest power of x's that I have is x to the 1 power. Y's. The smallest power of y's that I have is y to the 3rd power. So I'm going to pull that out. And next, I'm going to divide that out of each of my 3 terms. So 32 divided by 2 leaves me 16. I have 3 x's, take out 1, leaves me x squared. Had 3 y's, take out all 3, don't have any left. 120 divided by 2 gives me 60. I have 1x, take out the x, no x is left. 4 y's, take out 3, I have 1 y left. Here, 42 divided by 2 is 21. I had 2 x's, take out 1, I have 1 left. I have 3 y's, take all 3 out, I have none left. Now here's why I'm done. Because I know that 16 and 21 have no factors in common. So I can't pull any more numbers out. It has to come out of all 3 in order for me to take it out. And this term has a y, this term has an x. They don't have any variables in common. So I can't take any more variables out. So I am done. And my greatest common factor is 2x y to the third. Let's do the next one. When I look at this and I know my multiplication tables, I know each of these is in the multiplication table for 11. So I'm going to take out 11. I look at the x's, and my smallest power of x's is x to the 1 power. So I'm going to take out an x. My smallest power of y's, well wait, this one doesn't have any y's, so I can't take y's out at all. Alright, so let me see what I have left after I take out 11x. 132 divided by 11 gives me 12. I have 1x, taking it out, none left, and I have a y to the third left. 44 divided by 11 is 4. I had 2 x's, taking 1 out, 1 left. 99 divided by 11 is 9. Had 1x, taking it out, none left. Y to the fourth is going to come down. Now, I know I can't go any further. Here's why. 4 and 9 have no factors in common. Can't pull out any numbers. X and y to the third, no variables in common. Can't pull out any variables. So my GCF equals 11x. Now here's what I'm going to do next. I'm going to use this process for finding the GCF to factor a polynomial. And the way that I'm going to factor it is by factoring out its greatest common factor. So let's take a look at an example of this. Here is a factor. It's a monomial. Here is a factor that is a binomial. If I distribute, I get this product that's a binomial. This is multiplying or distributing. If I go in reverse, I'm starting with my product. I'm going to find my greatest common factor. That goes here. And what's left after I pull out my greatest common factor? That goes here. Because when I distribute it, I get what I started with. That's what we're going to do next. So the step 1 to find the greatest common factor, our step 1 to do this is find the greatest common factor. And step 2 is to factor out the greatest common factor using distribution backwards. So let's start with a real easy one, 6x minus 18. What goes into both? 3. 6 divided by 3 is 2x. And 18 divided by 3 is 6. Bring down my minus sign. Well, look, guess what else goes in here? 2 goes in here. So we'll pull out a 2. 2x, 2 divided by 2 is 1, so that leaves me with an x. Bring down my minus sign. 6 divided by 2 leaves me with a 3. This is really important. You're going to use 2 things here. This is your GCF, but you're also going to use the x minus 3. And the way that you're going to write this is like this. 3 times 2 is 6, and then in parentheses, x minus 3. And you can check that you've done this correctly by distributing. 6 times x is 6x, 6 times negative 3 is negative 18. This is what we're doing now. All right, so let's go to our next example. And what can we take out of both? A 10 and a 25, we can take out a 5. And that leaves us with 2x to the third minus 5x squared. Now, if we look at our variables, the smallest power of x's that we have is x squared, so let's pull out x squared. When we pull out x squared, we're going to have a 2 left, and I had 3, I'm taking out 2, I'm going to have 1x left. Here, I'm going to have a 5, I had x squared, I'm taking them both out, I won't have any left. 2x and 5 have no more factors in common. This that I'm ending with is important. My GCF is 5x squared, and I'm going to multiply that by 2x minus 5. If I distribute this, I will get 10x to the third, which is here, minus 25x squared, which is here. This is factoring out the greatest common factor. All right, let's do a few more examples. So here's a trinomial. And what I can pull out of this is 15. I know 15 goes into each of these. It goes into 45 3 times, and then I have x to the third. Bring down my minus sign. It goes into 15 once. Bring down my x squared. And 15 divided by 15, this gives me 1. And it's really important that when this happens, you don't forget that 1. You need to make sure you include that 1. Because when you factor this, it's going to look like this. 15 times 3x to the third minus x squared minus 1. If you don't have the 1 there, when you distribute, you won't get the minus 15, and you will have an incorrect answer. All right, let's go to B, and we'll do this again. What goes into all 3 of these? By my multiplication tables, I know that 7 does. I'm going to look at my variables, and my smallest power of x is just 1, so I'm going to take out a 7x. 35 divided by 7 is 5. Taking out 1x leaves me with 2. 7 divided by 7 is 1, and I take out 1x, that leaves me with 1. 14 divided by 7 is 2, and when I take out that x, it leaves me with none. And I have no factors in common here, so this equals 7x times 5x squared minus x minus 2. Third one here. Looking at all 3 of these terms, what can I take out? Well, first of all, I can take out a 3. My smallest power of x is x to the 1, so I'm going to take out an x. My smallest power of y is y to the 1 power, so I'll take out a y. When I divide, 3 divided by 3 is 1. I'm taking out the x. I'm taking out one of these y's, so it leaves me with just a y. Bring down my minus sign. 15 divided by 3 is 5. I had 2 x's. Taking 1 out leaves me with 1. Have 1 y, and I'm taking that out, leaves me with none. Bring down the plus. 12 divided by 3 is 4. I have an x and a y, and I'm taking out both of those. So I just have a 4. And so my factored form of this is 3xy times y minus 5x plus 4. Now, when you are doing these problems, it is not enough to do this. You must answer like this. In this form. You must do it this way. I will mark it wrong if you do not write it this way. This is showing your work to get there. This is your answer. All right, let's go down. Sometimes you may find it useful to be able to factor out a negative number from a polynomial. All right? And we'll get to when that happens, but sometimes it's very helpful. So here's an example, and we're going to factor out first a positive GCF from this expression using the distributive property. So here, my GCF is just a 2. I'm factoring that out, leaves me with 12 plus 3x minus x squared. All right? Instead, factor out a negative GCF from this expression using the distributive property. And here's what's going to happen. This sign is going to change because you're factoring out a negative GCF. See these signs here, positive, positive, negative, all going to change. Negative, negative, positive. All right? The reason why I did this is because I want to write this in descending order, x squared minus 3x minus 12, and I don't want this to be negative because when we get to the next kind of factoring, you will find that it's painful when this is negative. So I wanted it to be positive. All right? Both of these are correct ways of factoring this particular polynomial. It's just that sometimes factoring out the negative is more useful for the next step, which we'll get to shortly. So let's go ahead and turn the page to page 4 of our notes. And we've got some examples. And it says factor out a negative GCF from this expression using the distributive property. So what I want to do, look at what goes into all 3, which is 5. I'm going to factor out a negative 5. It's going to change all 3 of my signs. This is going to give me a negative 1, a negative 2x, and this negative will become positive 6x squared. And I like this because now I can write this in descending order and my first term's positive. So I'm going to write 6x squared minus 2x minus 1. Writing it in descending order will make the next step that we get to in a couple of days that much easier. All right, this particular one, I want to factor out a negative because the directions tell me to do that. My smallest power of x's is 1x, so negative x. And my smallest power of y's is 1y, so I'm going to take out 1y. When I do that, this part of my answer will be negative, this part will be positive because both change sign. When I take out 1x from 1x, I have none left. I had 2 y's, take 1 out, that gives me a y. Here I had 2 x's, I'm taking 1 out, that leaves me with an x. Here I had a y and I'm taking it out, so I have no y's. So my greatest common factor, negative xy, and what I have left, instead of writing this as negative y plus x, I'm going to write this as x minus y. I'm just changing the orders so that I have a prettier binomial. All right, the last thing we're going to do today is going to set us up for what we do on Wednesday, which is factoring by grouping. What we're going to be doing is factoring out a greatest common factor that happens to be a binomial. So let's take a look at this first example. This is my expression. My greatest common factor here, I have 2 terms, this term and this term. My greatest common factor is actually 7x minus 1. That's my greatest common factor. It's common to both of my terms. So I'm going to factor it out to the front. See, it comes out to the front. And what's left is 5x squared minus 3. And if you want to see this as a box, in front, bring out the 7x minus 1. When you divide that out right here, you're left with 5x squared. When you take the 7x minus 1 out of here, you're left with minus 3. So 5x squared minus 3. So the way that this ends up looking is like 2 binomials. And what we call this is factoring out the greatest common factor that happens to be a binomial. So let's go ahead and do the next one. What's common to both? Both this term and this term is the 3x minus 4. Factor it out to the front as your greatest common factor. And what you have left after you divide it out is 2x plus 1. All right, the last example is a little bit trickier because these aren't the same. So you cannot do this. Here's the issue. These two terms happen to be opposites. They're the same two numbers, both minus, different order. All right, they're opposites. It means they're the same number, just one's positive and one's negative. So here's what we're going to do. We're going to factor out a negative 1 from this one right here. So what we're going to have, this part will stay the same. When you factor out a negative 1, this becomes negative 4. And in parentheses, this becomes negative 3 and positive y. Because remember, when we factor out a negative, it changes all the signs inside the parentheses. So really, if I put that in a different order, let's rewrite this. 3y squared times y minus 3 minus 4. And instead of writing negative 3 plus y, I'm going to write positive 3 or positive y minus 3. Notice, the signs are still the same. I just changed the order. That's all I did. This went here, this went here. It's just so that they look identical. Because if this and this are not identical, you cannot do this. All right? So now I'm going to bring that y minus 3 to the front. What is left is 3y squared minus 4.